two triangles that have the same shape but not necessarily the same size are called similar triangles. Corresponding angles of similar triangles have the same measure. More importantly for this lesson, the ratios of the lengths of the corresponding sides are equal. So in this case, we have this 3, 4, 5 triangle and a 6, 8, 10 triangle. And if we pair up the common sides, pair up the 3 to the 6, the 4 to the 8, and the 5 to the 10, you see that 3 divided by 6 is the same thing as 4 divided by 8 is the same thing as 5 over 10. So basically, we can form proportions from the sides. So find the length of x in the small triangle. Assume the triangles are similar. That means that the corresponding parts, the ratios of the corresponding parts should be equal, and we're able to find a proportion from that. So match up the x to the 12.6 and the 10 to the 18, and we would have x over 12.6 is equal to 10 over 18. So we solve this by taking cross products. X times 18, or 18x, is equal to 10 times 12.6. That would be 126. And then x would be 126 divided by 18. So 126 divided by 18, we get 7. And that tells me the length of the small side is 7. And where it gets a little tricky, something like this, where you really want to make sure you link up the corresponding parts. So let's find the length y in this in the large triangle. You can assume they're similar. That means the largest sides should match up, the smallest sides should match up. And from the looks of it, the 10 is the largest side, and the 15 would match up. So 10 and 15 would match up, and the smallest sides would be the 5, and looks like the y. So 10 over 15 is equal to 5 over y. And if you do cross products, 10 times y is equal to 15 times 5. So 10y is equal to 15 times 5 is 75. If you divide by 10, y would be 7.5, 7.5. So the length of y would be 7.5. And that makes sense. If you look at the left triangle, you have the 10 and the 5. 5 is half of 10. 7.5 is half of 15. So find the perimeter of each triangle. Assume the triangles are similar. The perimeter of the triangle is found by adding the lengths of all three sides. So for the left one, the perimeter is going to be 7 plus 4 plus 10.5 meters. And so we have 11, 21.5 meters. Okay, for the right side, we're going to have to do some proportions. So the one we know, I know I can match the 7 meters with the 10 meters. And the 10.5 meters matches up with y. So we have this 7 over 10 is equal to 10.5 over y. So that tells me that 7y is equal to 10 times 10. So 7y is equal to 105. And so divided by 7, 105 divided by 7 is 15. So y would be 15 meters. And then for the other one, I would also start with 7/10, but I would match up the 4 meters with the x. So 4 over x. And so what we have here is we would have 7x is equal to 40. So x would be 40 over 7. Or that'd be 5, and that'd be 5 times 7 is 35, and 5 left over. So 5 and 5/7 meters. And so the perimeter for this right one, the right triangle, the triangle on the right you see there, is we have one side is 10, one side is 15, and the other side is 5 and 5/7. So that's going to be 25 or 30 and 5/7 meters. All right, for one last question. Find the height of a flagpole that casts a 48-foot shadow if at the same time a 6-foot pole casts a 9-foot shadow. And we'll assume that the sun or the moon, whatever's causing the shadow, this will cause similar triangles. So that means I can match up the 9 with the 48, and the 6 with, I can match up, let's call that x. So what I have here is that 9 over 48 is equal to 6 over x. So 9x is equal to 6 times 48. And so x would be that 6 times 48 over 9. And so I'll just pull out the calculator. 6 times, oops, wrong way. Clear. 6 times 9 divided by, one more time. 6 times 48 divided by 9. There we go. And we end up with 8. So the flagpole is, wait, that can't be right. Let's try that again. Ah, that's why. All right, so let's try it. 6 times 48 divided by 9 gives us 32. That makes more sense. All right, so 32. So in this case, the flagpole is 32 feet tall.